Hello everyone, in this section we will learn about covalent compounds and their nomenclature. A covalent bond is formed when two nonmetals combine with each other. Now the reason behind the formation of covalent bond is again to achieve stability by completing their octets. Now we have learned previously that nonmetals tend to gain electron. Hence formation of ionic bond is not a possibility here because none of the two nonmetals would like to lose electron. Therefore they complete their octet by sharing the electron instead of transferring. Let me explain this with the help of an example. Let's take a look at chlorine. Now chlorine is a nonmetal and it is present in group 7A. Now, because it's in group 7A, hence it has 7 valence electrons. So these valence electrons are represented by dots, and this is known as Lewis dot structure. We show each electron on each side by a single dot. Once you complete all 4 sides with one dot, and if you still have extra valence electrons, you start pairing them up. So we have 7 valence electrons, so we will have this kind of structure. So now to complete octet, all elements need 8 valence electrons. Now chlorine has 7, so it needs to gain one more. As we already discussed that in case of covalent compounds, or nonmetals combine with another nonmetal, so there is no other element present which is going to donate electron to it. So imagine if there is another chlorine atom nearby, and that chlorine atom also have 7 valence electrons. So I'm gonna call this number 1 atom and number 2 atom. Now both wants to complete their octet. So what they will do is, instead of transferring the electron from 1 to 2 or 2 to 1, they will share the electron. So sharing means this unpaired electron will come in the middle and this unpaired electron will come in the middle, and they pair with each other in such a way that the shared electron is right in the middle, and then the other valence electrons are around the atom. These two electrons, these are called shared pair of electron. Now shared pair is the covalent bond. We can represent covalent bond with a line also, but it is understood that the line represents two shared electrons. Other electrons around the chlorine atoms, these ones, all of these electrons are known as lone pair of electrons. So we can say that covalent bond forms as a result of sharing the electrons. So this example shows a covalent bond between hydrogen gas. So hydrogen gas is represented by H2, and there is a covalent bond between two hydrogen atoms. In some cases, more than one bond is also possible. For example, let's take a look at oxygen. So oxygen atom has 6 valence electron because it is present in group 6A. So I'm going to represent those 6 valence electrons this way. So if oxygen wants to achieve stability, it needs to have 2 more electrons. And so neighboring oxygen will also have 6 valence electrons. So this electron will pair with this one to form a covalent bond. This electron will also pair with this one to form a covalent bond. So our oxygens will look something like this one. So now this is an example of double bond formation. So depending on how many valence electrons we have in around our atom nuclei, it is possible to form one single bond or a double bond or a triple bond. So this is an example of double bond formation. Now that we have learned what are covalent compounds, let's learn how to name a covalent molecule. Before naming any molecule, please make sure whether that molecule is a ionic or covalent. One easy way to find out is by looking at the composition. If the molecule is made up of metal and non-metal, then that molecule is an ionic molecule. If a molecule is made up of non-metals only, then that molecule is a covalent molecule. So let's look at these examples. So our example A and example B both are made up of nitrogen and oxygen. And we know that both nitrogen and oxygen are nonmetals, hence these molecules belong to covalent molecules. So there are two steps in naming a covalent molecule. So step number one is you look at the molecule and find what is the first nonmetal, and then you write the name of that nonmetal as such. For example, in this case, our first nonmetal is nitrogen, hence we will write the name nitrogen. So the name will begin with nitrogen. Now the second nonmetal, you name it and change that name by removing last three letters of that nonmetal and adding the suffix "ide." For example, oxygen, we're gonna remove the last three "gen" and we're gonna make add "ide" to it, so oxygen will become oxide. And so in example B also we have nitrogen. So first part of the name will be nitrogen and the second part will again be oxide. So in step number two, we will identify how many atoms of each nonmetal is present, and we will add a prefix to show the number of atoms of each element. For example, in first case, we had NO2, so we had one nitrogen and two oxygens. So the prefix for one is mono and prefix for two is di. So technically the name of this one will be so in step number one we write its name to be nitrogen oxide. Now we need to identify how many atoms of nitrogen and how many atoms of oxygen are present. So we saw that there are one nitrogen, so prefix for one is mono and prefix for two is di. So technically the name of this compound should be mononitrogen dioxide. There are a couple of exceptions, I'm gonna go over it, but that's all the nomenclature you need to know so far. So the exception is the prefix mono is omitted from the beginning. So hence we will not use mono in the beginning. So the correct name for NO2 is nitrogen dioxide. So we already established the name of NO2, so it is nitrogen dioxide. So let's look at the other example, so N2O4. So in this case, we have two nitrogens and four oxygens. So the prefix for two is di and prefix for four is tetra. So the name will become dinitrogen tetraoxide. There is another rule is that whenever two vowels are together, we omit the first vowel. Hence the correct name is dinitrogen tetroxide, not tetraoxide. So this is all about covalent compound nomenclature. It is relatively easy as compared to ionic compound nomenclature. I'm going to upload another video in which I will discuss different kind of problems related to this nomenclature and other topics from chapter number 3. So far, if you have any question, please contact me by email. I really appreciate you guys watching this video and have a wonderful rest of the day. Bye bye.